go over the whole thing so we can finish it so everyone knows what. Now, what I would do in preparation for this test, I would definitely go over the checklist, everything that I turn in here, because I'm going to post solutions, right? Number one. Number two, I will definitely look at the problems that we did in class. Just browse through your notes, okay? And definitely look at this. So you're going to have a little bit from everything. A little bit of limits, a little bit of, but since limits are so different, so many different, or such a big variety, you're going to have like here, I don't know, maybe 5, 6 questions. Then, of course, you're going to have the difference quotient in the sense that as f prime of x and f prime of a. Of course, the intermediate value theorem. Of course, the squeezing theorem. So that's pretty much it. That's all we discussed. Of course, you will have to graph a piecewise defined function. There is no secret there, and answer some questions. You will have something like this in which you have to present your work. So pretty straightforward. Nothing that you have not seen in class. I don't do that. Okay, so yes, please.
Post this once we finish it.
You mean the test?
Yeah.
Yeah, we're going to finish it now.
Okay.
Yeah, we're going to finish it now. Okay, anything else? Okay, so let's start then. Would you like to go in order? You want to jump around? You have a particular... Okay, so we have limit.
Is this the test or the checklist?
Oh, no, the checklist will be posted. I will post the solutions for the checklist. No, I'm thinking of the test, but unless you have other questions. Do you have other questions for
On
me?
the checklist.
Okay.
But if you're going to post the
I am going to post the solutions, but if you want to choose a similar example to work on.
we can do the test.
Okay, so let's continue with the test then. So we have limit as x approaches infinity from e to x minus x squared. Now, we haven't gotten to chapter 3 yet, as you already know. But when I look at this function, I know it's a function composition. There is an inside function and there is an outside function. When you look at this, which one is the inside function that we will have to evaluate first? That's the inner function. And which one will be the outer function that needs to be evaluated after we evaluate the inner function?
You have to go through the exponents.
So the exponent is the power of e is the inner function. This is, if you ask me evaluate this for 5, I cannot raise e to something. I have to evaluate this first. Once I get the number, then I will say e to that number. So the inner function is this, the power, and this is the outer function, e to the x. So let's say g of x equals x minus x squared is the inner function. And the outer function, let's call it f of x, is e to the x. So like before with this function, okay? So when we analyzed this last time, and we did, right? We did this last time?
Yeah.
Okay, so that's why we started with the inner function. The inner function is 1 over x. Once I'm done and I get a number here, then I apply arctangent to it. So arctangent is the outer function. 1 over x is the inner function. Agreed? That's why we had to evaluate the inner function first. So we said, okay, when x approaches 0 from the right, where does the inner function go? Yes, right here, right? So now I'm asking myself, as x approaches 0 from the right, which means this quantity approaches infinity, where does arctangent go? Right, from the graph. Okay, perfect. The same thing here. I have to analyze where x minus x squared goes first, and then decide what to do next. So first, we address the inner function. So I'm saying to you that e to x minus x squared is nothing else but f comp g, the function composition of f and g. So I apply g first, and then I apply f to g, and you will get this. So therefore, I'm asking myself, when x approaches infinity, where does this go?
Negative infinity.
Right, because this is the most powerful, this doesn't matter. It's too small. And since this has a negative leading coefficient, this will be negative infinity. Agreed?
Yes.
Now I have to ask myself, e to negative infinity, where does that go?
0.
And the answer is indeed 0. Because e to negative infinity is approaching 0 as x approaches infinity. Good? Yes? Okay. So do we have any answer for this? Anyone worked on this one?
I didn't. I got a DNA.
Okay, that's possible. So let's take a look. Limit as x approaches 2 from either side. Yes?
Did you say the last part from the e to x minus x squared? Do you do like the limit of e to x
Yes.
as x approaches negative infinity?
So e to negative infinity, e to negative infinity, I shouldn't write this
Oh, okay.
because it's not legitimate,
Oh,
is e to infinity, which means 1 over infinity, which means, so all these equal symbols should not be there. This is not legitimate, okay?
Right.
So I have to use the limit. This is not mathematically correct because I have to use the limit. So e to negative infinity is 1 over e to infinity. That's okay. But I cannot say that this equals 1 over infinity. But that approaches infinity when x approaches infinity. Yes. So then that's the reason why eventually we get 0. And I should write here that y equals 0 is a horizontal asymptote at infinity. For sure. Any questions so far? Okay. So then when we work on the next one, I cannot do anything here before I completely simplify the function. Where do I start? And you will have something like this, and I will specify. You must simplify the function and show all your work before you find the limit.
So it's
Where do I start?
it's either x plus 2x minus or minus x.
I have to start with the absolute value of x. So this is the requirement. So that's my starting point, the absolute value of 2 minus x. And I know that this has two possibilities. What are those possibilities?
2 minus x. Yes. If x is greater than or equal to 0.
No. 2 minus x, if 2 minus x is greater than or equal to 0.
Oh, right.
And the other one is the opposite of 2 minus x if 2 minus x is less than 0. Remember, these quantities have all to be the same, all identical. The only difference is here. Okay. So now I continue. 2 minus x or negative 2 minus x, do not change anything here, do not distribute. And I have to solve this, which means x less than or equal to 2. I will never solve this one, because if this is less than or equal to 2, this must be, of course. Right? When I move negative x to this side, x is less than or equal to 2, and this must be greater than 2. Now I'm going to try to simplify the entire function. Let's write it. 2 minus x over the absolute value of 2 minus x has two options. What is the first option?
Two.
2 minus x over 2 minus x is 1. I no longer can put the equal symbol here. Why I can no longer put the equal symbol? Because now this quantity is in the denominator. I cannot have 2. And what is the other option? When I have this at the bottom, so this, exactly, negative 1 for x. Very good, greater than 2. Perfect. Only now I'm ready to look at limit as x approaches 2 from the left and limit as x approaches 2 from the right. I need to because the limit specifies x approaches 2 from either side. So I have to determine the left and I have to determine the right because this is a piecewise defined function. So limit of the function when x approaches 2 from the left.
How did you get the 1 and the negative 1 right there?
2 minus x over 2 minus x is 1. 2 minus x over the opposite of 2 minus x is negative 1. Better?
Okay, yeah, perfect.
Perfect. So now limit as x approaches 2 from the left, which function? Very good. So this is 1. So the limit as x approaches 2 from the right, from which function? Good. And the answer is negative 1. Therefore, the limit of this function as x approaches 2 from either side from 2 minus x over the absolute value of 2 minus x must be indeed perfect. Very good. But we have to justify these steps. We had several with the absolute value. Please don't forget the limit handout. Yes, the first 2 pages of the limit handout. Okay, so I think we did this problem in class together, but let's do it again. Do we have an answer for limit as t approaches 0 from 1 over t minus 1 over t and t plus 1? When we are asked to evaluate a limit, what is the first thing that we need to do?
Plug it in.
Correct. However, I can't. So at this stage, I cannot plug it in yet. So what should I do then?
Lowest common denominator.
Very good. So let's find the least common denominator. And that would be
T
squared. T plus
very good point. We never multiply the factors in the denominator. Make yourself a note if you need to, that's fine. We never distribute, we never expand the factors in the denominator. They have to stay in the factored form. Okay, so then the adjustment for the top of the first.
T plus 1.
And for the last one?
Nothing.
Very good, or 1, perfect. So then the numerator becomes t plus 1 minus 1. I simplify positive 1 with negative 1. And I get limit as t approaches 0, t over t times t plus 1. Now I plug it in. What do I get when I plug this in?
0.
Of course, which means there is hope. Do we know what factor we need to eliminate for sure? If the limit exists, there is one factor that is in the way. Which factor will that be?
T.
Exactly. Or t minus 0 if you want. That's the factor that has to go away. And luckily for us, it does. So then the limit is, and now and only now I drop the limit operator. The limit operator goes away. So
1.
very good. The numerator goes to 1. The denominator, when t approaches 0, it goes to 1. So 1 over 1 is indeed 1. Perfect. Well done. Questions? Is this clear? Do we understand all steps? Is it a yes? Anyone? Questions? Okay, perfect. So now the next one is limit as x approaches 3 from the square root of x plus 6 minus x divided by x cubed minus 3x squared. I'm given a limit. I'm asked to evaluate it. What do I do?
You plug it in, you get 0 over 0.
Yes, if I plug it in, I get indeed 0 over 0. Good.
So multiply by the conjugate.
Very good. I will multiply by the conjugate, and I'm lazy, and I'm going to put it in there. So it's x plus 6 plus x, the square root of x plus 6 plus x. We agree? Perfect. So then limit as x approaches 3. If we get 0 over 0, which factor do you hope to remove from the top and bottom if the limit exists? Which factor?
X minus 3.
Thank you very much. Very good. So then the top. And I will also factor out what here?
The x squared.
Perfect. So I have an x squared, and I have an x minus 3, and I have this. And now can anyone dictate the top?
X plus x minus x.
Very good. Perfect. Okay. What do you think we have to do next?
Factor out a minus.
Very good. Yes. Because otherwise I will not be able to cancel this. If I don't rearrange in descending order and factor out the negative leading coefficient, I will not be able to remove the problem. One more time, the problem is? Perfect. Okay, so now I will continue by factoring the top. How do I factor that? X plus 2 times? Very good, awesome. Well done, guys. So limit, x approaches 3, negative, you said x plus 2, and you said x minus 3. And this is x squared and x minus 3, and the square root of x plus 6 plus x. And now what? Of course, I got to where I wanted it to be.
Cancel out the x minus 3.
Yes. And now I can drop the limit operator. The numerator goes to
X plus 2. Or negative x minus 2, sorry. Or negative x plus 2.
I'm dropping the limit operator.
X minus.
I'm dropping the limit operator.
-3.
Negative.
5.
5.
Very good. Awesome. Over.
54.
Yes. So this is 9. Very good. And this will be 3 plus 3, correct?
Yeah.
So I have negative 5 divided by 54. Any questions? Any questions? Anyone? Is this okay? Yes? Okay. Moving on. Limit. As x approaches infinity, from the square root of x squared minus 9 divided by 2x minus 6. We're given a limit. First step.
Can't use split.
Plug
So-
it in. 1 second.
Oh, yeah. So it's,
Good. Very good. Okay. So now what is the setup for this? Because this is also different than everything else.
Square root of x minus square root of
you can do square root of x squared times the square root of 1 minus 9 over x squared on the numerator. Factor in. Alright, cool.
The square root of 9 minus 4 will never equal the square root of 9 minus the square root of 4.
What the hell did I do?
Because this is the square root of 5, and this is 3, and this is minus 2. So the square root of 5 will never equal 1. So when we take a square root from a product, we are allowed to do this. 1 second. If we take the square root of a ratio, we are allowed to do this under certain conditions. We assume both of them are positive, because if this is -3 and this is -2, I cannot do this, right? Okay. But when we take the square root from a plus b or minus b, this will never be able, we will never be able to simplify this, ever. This is never the square root of a plus or minus the square root of b. So please remember this. It's very easy to forget, right? So please remember this. We can never split a radical if the radicand or the quantity under the radical is a sum of terms or a difference of terms. If the radicand is a product of factors, yes. If the radicand is a ratio of factors, yes. But if it is a sum of or difference of terms, no.
Man, it looks so good.
I know. That was cute.
Shattered my confidence.
Yes.
I would have done the same.
Yes.
You factor it, that's
What will I factor?
x squared minus
I cannot factor x squared minus 9.
In case you factor out the x squared, so you got up with 1 minus 9 over x squared.
Very good. So we factor out x squared. And what do we factor out in the denominator? What is the degree of the denominator?
X.
Very good, which is degree 1. So I have to factor out x. So be careful with these, because of course this is the, I would say, the most difficult type so far, right? In which I have to take by force a factor out, because now I can split it. Why I can split it? Because it's a product. So now I'm in this situation
Okay.
in which I have the square root of x squared times the square root of whatever. So this is allowed, but this is not allowed. Okay, good. So what is left in parentheses under the square root?
1 over 1 minus 9 over x squared.
Very good. What is left in parentheses? You can. It would be nice if you wanted to, but it doesn't matter right now. You don't have. I know the greatest common factor is 2, but we have to force out the degree.
2 minus 6 over x.
Very good. Awesome. So far, so good. So I'm going to circle this, and I'm going to continue on the next page. So what now?
Now you can separate.
Yes. Now I can write limit as x approaches infinity from the square root of x squared times the square root of 1 minus 9 over x squared. And then I have here to x, and I don't have to do anything in the denominator anymore for now. So put these, that's why I created a document for limits. So you have at least one example from all possible types. So we only covered the first 2 pages. So please make sure you practice from each and every one. Okay? Is that clear? Okay. So now I have to ask myself what this is. I cannot jump and conclude anything before I look where.
It's the absolute value of x.
Correct. But it will give me the answer when I look here.
Positive.
Indeed. So because x approaches infinity, it's clear that the limit as x approaches infinity is going to be x, the square root of 1 minus 9 over x squared, divided by x, 2 minus 6 over x. We had way more sophisticated problems than this one. I think, I'm not saying that this is easy. I'm saying it takes a while, right? So it's not, the easiest of all. Good. So what do you think we are going to do next? Right. So that was the whole purpose. Right. So now, where is this going?
0.
Where is this going? Good. So where is the numerator going now? Only now I drop the limit operator. I'm done with it. So the top goes to,
Square root of 1.
which is 1, and the bottom goes to, so that's the limit. I have to write and identify what this means. When I'm told the limit of a function as x approaches infinity is 1/2, there is a specific significance. Very good. Y equals 1/2 is the horizontal asymptote, and I have to specify. I use the sign. This is very important. So it is at infinity. Good. Other questions here about these limits? Anything? Yes, please.
For that one,
Yes.
how would you know to do what we did as opposed to like multiplying the conjugate to get rid of the radical?
Very good. Because there is no conjugate for a radical. I need, for the conjugate, I need 2 terms. I don't have 2 terms. It's a very good question, actually. It's a very good question. Thank you. I don't have 2 terms. This is just 1 term. So if I multiply and divide by the same thing, I will only move it to the denominator.
But if there was, you would prefer the conjugate over that process.
It depends on what I have in the denominator, but yes, I would say yes. Good. Other questions? Very good question. Excellent. Excellent. Okay. So did we have any difficulties with the intermediate value theorem? Do I have to show that?
A little bit.
Okay, let's do it. Let's do it together. Okay, very good. So we have 2x cubed minus 8x squared minus 7 equals 0. It says state a theorem and its hypothesis, find the interval where the solution exists, and it has to be, I should have mentioned, but I thought it was clear, but I will mention it when I write your test. I have not written it yet. That the interval has to be a 1 unit length. You cannot say there is a solution between 0 and 10. You have to say there is a solution between 3 and 4, or between 5 and 6, or between -3 and -2. Okay, it has to be 1 unit length. Okay, so I have a function, which is 2x cubed minus 8x squared minus 7. The first hypothesis, which is extremely important, is that the function is continuous everywhere. You can put negative infinity to infinity on S A
It's greater than 0.
S A. Why is it continuous everywhere? I have to explain why. It's as a polynomial function. Very good. We have to write that down so we specify why. In number 2, I have to find with the calculator 2 values, 1 unit interval from each other, bless you, such that where the function does what?
Crosses the x-axis.
Changes sign. If it doesn't change sign, no. Sorry about that, I wasn't ready. So if it does not change sign, then the theorem, if it doesn't change sign anywhere, then the theorem is not applicable. However, what type of function is this?
Polynomial.
Yes, furthermore, exactly, polynomial, furthermore, what type, what degree? It has to cross at least once. There is no other way. It could cross 3 times, but I am only asked to find one solution. But it has to cross at least once. If it has a positive leading coefficient, it looks like this. If it has a negative leading coefficient, it has to look like this. So it must cross at least once. It cannot cross twice. It's either once or 3 times. Okay, so in y equals, I'm going to punch in this function, 2x cubed, and then minus 8x squared, and then minus 7. Yes, I can graph it and then figure it out. That's fine too. I already see it here. The software gives me a very good. So obviously it's between 1 and 2. And let's check with second and table. Oh, of course. I'm sorry. I have to change that all the time. Okay. Second and table. I already see at 1 is going to be negative. At 2 is going to be positive. It depends on, let me see what I had here.
5. Yeah, I got 4 and 5.
Okay.
I got the same thing.
Okay. Yeah, the viewing window, yes, the viewing window is different. That's why I had to check. Very good. So I go back to second and table. Yes. 4 is negative. 5 is positive. That's all I need. So the 1 unit length is 4, 5. So I'll say f of 4 is negative 7. F of 5 is positive 43. So from here, from 1 and 2 and by IVT, which is not applicable if the function is not continuous, we conclude that there exists a C in the interval 4, 5 such that what?
The function of C.
Very good. If you remember, we said the intermediate value theorem does not solve the equation. It only says, here it is. It's right here between 4 and 5.
What's the 1 and 2?
1
Okay.
and 2, first hypothesis, the second hypothesis, and by the IVT, intermediate value theorem, there exists a C in the open interval 4, 5 such that f of C is 0. Is this okay?
Before the interval, does that mean by an open interval after the c. That's
Yes. So this exists from the epsilon delta, exists c in the interval, in. So this is the symbol for, so it's this, in the interval 4 comma 5, open, not 4 and not 5, open 4 comma 5, such that f of c is 0. Perfect. Moving on. Yes, please. Huh?
So would we need a calculator for the test then?
Yeah, you can use mine
Oh,
if you don't have one.
I just can't find it.
No problem. Other questions here? Okay, so next one. For the following function, do not graph its derivative, but find the intervals on which the derivative is negative, positive, and 0.
As it goes up, it's positive.
Exactly, because it's the slope of the tangent, right? So the function goes up, the slope of the tangent will be positive. So between 0 and 5 on this interval, the derivative is positive. And where else? Between 15, is it 15? 15 and 20. So I will say f prime is positive on the interval 0 to 5 union 15 to 20. Where is f prime 0?
The peaks.
Exactly, that's x equals 5, and also at x equals 15, right here. And where is the first derivative less than 0?
5 to 15.
Very good, that's it. Any questions? Yes?
Would it be
Oh, yeah, you put
0,
5
5, union 15? 0, 5, union 0, 15?
0, 5 union 15 to 20, when it's increasing.
Oh, no, for the,
bottom.
yeah, that one. So isn't that just
Oh, okay, yeah, okay, I got it.
Between 5 and 15, the function is decreasing, therefore its derivative will be less than 0.
Oh, I was,
It's the domain.
I was reading those as coordinates.
Yeah.
Oh, sorry. We're talking about x. But find the intervals on which the derivative is negative, not from which value to which value.
Yeah.
Very good. Any questions? Okay. Find the equation of the tangent line to the curve at 11, 3. How do we do this? So we are given y equals the square root of x minus 2, and we are given the point 11, 3. So we're asked to find the equation of the tangent line. And the equation of any line is y minus y1 equals the slope times x minus x1. Here is my x1, 11. Here's my y1. If there is a way of determining the slope, then I'm in business. That's all I need to do. But how will I determine that? And what does it represent, knowing that this is the equation of the tangent to the graph of this at that point?
The prime or the derivative.
Very good. We have to find f prime of
Square root of x plus h minus 2.
which is correct.
11.
Very good. Or another option is to find f prime of and plug in x equals 11 at the end. It's up to you. You can use this definition. There are 2 definitions for this and 1 definition for this, and at the end you plug it in. It's up to you. What would you like to do? You want to find the derivative and then plug in 11, or you want to find f prime of 11 with one of the 2 definitions? Okay, very good. So let's find f prime of 11. We have to decide which definition to apply. Last time we did the h1, a plus h, f of a plus h minus f of a over h. This time let's use the other one. So what is it? What do I have to write?
F of x minus f of a.
I cannot give any credit if we start with that.
So limit
Very good.
as
X approaches. Very good. The denominator is x minus 11, though I know exactly what needs to go away. What needs to go away? Which factor needs to go away?
X minus 11.
Perfect. And now the top. It's the square root of x minus 2 minus,
Square root of 11 minus 2.
which is? Very good. Perfect. And now, what will I do? Let's plug it in, of course. It's, Ellie?
So you're okay with us just jumping to 3 without writing
That's
the
fine.
steps of getting there?
Yes.
You assume we know.
Yes, I do. Have to assume.
so plugging in that's 0 over 0.
Exactly, of course. And then, so these are two terms.
Multiply by the conjugate.
Very good. Square root of x minus 2 plus 3 over the square root of x minus 2 plus 3. So this is limit as x approaches 11. I'll copy the denominator. And you will give me the numerator.
X minus 2.
Very good. X minus 2 minus 9. Awesome. And then x minus 2 minus 9 means what? And with your permission, I will do this. And now I can drop the limit operator altogether. And what is it?
1 over
Yes?
square root of x minus 2 plus 3.
Very good. But I cannot write that because I dropped the limit operator already.
Oh, 6.
Very good. The square root of 9 is 3 plus 3 is 6. Awesome. What do I do with 1 over 6 now?
Plug it into this.
Exactly. So I have y minus 3 equals 1/6 and x minus 11. Therefore, the equation of the tangent, any questions? Is 1 over 6x minus 11 over 6 plus 3.
I have no idea how I got this right.
That's okay. I'm happy.
Goodness.
1/6x. 6 times 3 is 18. 18 minus 11 is? Can anyone tell us again what this represents? The equation. It's more than just the slope. This is the slope. This is the equation of the tangent line to the graph of y at which point? Correct. So in other words, I'm going to just come up with a rough graph. What is the domain of the square root of x minus 2? Let's write the inequality. The inequality first for everyone to see. X.
Probably be
No one likes the square root. Just no one. Absolutely. I have to find one student who can say immediately x minus 2 has to be greater than or equal to 0 so you can take the square root from it. Not just one student. I have no idea. I don't know how to say it. Maybe it's me. I have no idea. Why is it so difficult for the square root to say it must be greater than or equal to 0?
My brain just shuts off.
Okay, I got it.
Yeah, I automatically
avoid them.
confused.
Good. So then I know where to start. I know where to start the function. Here it is, right? So this is square root of x minus 2. So at 11 comma 3, somewhere here, I have this tangent. And this tangent has this equation. So where this is 11 and this is 3. And it's this tangent whose equation is this, whose slope is 1/6. Is this okay, everyone? Good. Can we remember this from now on?
You would think.
Hopefully.
I'm ready to bribe you. 1 point.
Oh.
1 Okay.
It's like one note card. Are we in negotiation?
Oh, there you
No
go.
negotiation.
I'll
Find the
ask you
horizontal and vertical asymptotes of the function, including the pertaining limits. Ready? Good. Let's do it. So then f of x equals x minus 1 divided by x squared minus 3x plus 2. So we're given a function. What type of function is it? Awesome. So obviously those rational functions normally have what? Vertical and right. And they may even have holes in them. So what will I have to do first then? Correct. Awesome. Thank you very much. And x minus 2 times x minus 1. And I have, before I touch the function, before I do anything, I have to write what?
X is not equal to.
Can I equal to or 1?
Very good. Very good. Okay, now I can do something to it.
There's the vertical axis.
Not yet. Now I can do something to it. What will I do? But first I have to write this. What can I do?
So, 1 minus.
Very good. Okay, so then this is 1 over x minus 2, which we know right away that this will represent what, and this will represent what.
Yeah, asymptote and a hole.
Very good. Vertical asymptote, and this represents a hole. The factor that goes away is a hole. The factor that stays all the time and cannot go away must be, yes. Very good, awesome. So now I have a lot of work. First of all, I'm going to start with the horizontal asymptotes because I'm done quickly. The limit as x approaches infinity or negative infinity, doesn't matter. It's the same. Of 1 over x minus 2 is, without doubt,
0.
very good. So y equals 0 is a horizontal asymptote everywhere. But then I have to determine the limit as x approaches 2 from the left. Limit as x approaches 2 from the right. Limit as x approaches 1 from the left. And limit as x approaches 1 from the right. Yes, Sally, please.
What is in the parentheses under the first limit?
Infinity or negative infinity doesn't matter. I'm not going to use the sign. So I don't have to write it twice. Yes?
Y equals 0 is a horizontal asymptote.
Yes, and it doesn't matter. It doesn't matter. This will not have two different asymptotes. I did not use the sign of the infinity. If it's 1 over positive infinity or 1 over negative infinity, it doesn't matter. So that's why I'll say it's a horizontal asymptote, and that's good enough. Is this okay? So now let's find the limits. I know it's 1 over 0, and I know it's undefined. So I know the limit doesn't exist. 2 from the left. 1.9. 1.9 minus 2 will be? Very good. And 2 from the right? Very good. We need this in chapter 3. That's why we're working on them right now. Okay, so now when I plug in 1 from the left or from the right, it's not going to make it a difference, but I have to write it like this. What will the answer be?
-1.
Very good. So this is clear that the whole will be which ordered pair?
-1, 1. Or
1 minus 2 is -1. 1 over -1 is -1.
1, -1.
Very good. That's it. Thank you.
Where'd you get the one for, where'd you get the positive? Okay.
Why don't you use like one?
Very good question. Because 1 is in the domain of this function. This is not an indeterminate case, and it's not an undefined case. It's 1 over negative 1. So this number is in the domain of this. However, this number is not in the domain of this. But I have to use the simplified form. So 1 is in the domain of this function, so I don't have to think about left and right. I do in this sense, but I don't have to worry about
And 2 isn't in the domain of that function.
2 is not. Yes, that's why I have 1 over 0, 1 over 0, and that's how I get the vertical asymptote. Here I get the whole, and I can plot it, because that's the point. That would be an open point. But here I have a vertical asymptote. A very good question. Okay, next. Find the limit or show that it does not exist. We have 2 limits here. I think we did the first one, but we can do it again. Or something similar. It doesn't matter. So we have limit as x approaches infinity from the square root of x squared plus 4x plus 1 minus x. I said that all the time to my students. I'm telling you too. I learn from you. So for example, this was one question that Nico said. I would have not come back and said, okay, this is, okay, that was one. Another question that I had from another student yesterday, she said, okay, what's the difference between factoring and using completeness square? I never thought of saying that. And to explain what is this and what is that. Completeness square has a particular number on the other side. Factoring doesn't have to have. So you can still complete the square. So you can still get something squared, but not necessarily a different number other than 0 on the other side. So you are making me better. So what do we do? What is the first thing I have to check? Right, it is infinity minus infinity. It's an indeterminate case. Who knows what we're going to come up with? No one does. So what, in this case, what is the only chance?
Conjugate.
Good. So the square root of x squared plus 4x plus 1 plus x, and the square of x squared plus 4x plus 1 plus x. And then the other question, right, Joey, that you had last semester? With the synthetic division, I remember that now. Synthetic division, the remainder theorem, and the factor theorem. Good. Okay, next. Yes, if I don't write the limit, I'm in trouble. Because it's not the same. You understand it, without the limit, they cannot be the same. Okay, very good. So I'll copy the denominator. And you'll tell me the numerator.
X squared plus 4x plus 1 minus
X squared.
Very good. First term squared minus the second term squared. So, of course, I will simplify these two. They cancel out. And now, what do I do to the top? Definitely, for sure. What is the degree? What do I factor out? Very good. What do I get?
4 plus 1 over x.
Awesome. What do I do to the denominator? I factor out, not yet, but I have to show. X squared is the degree inside. Good. What do I have left?
So 1 plus
Yes?
4 over x plus 1 over x squared.
Awesome. Thank you. And now, limit as x approaches infinity. The top has to stay. And now the denominator, I have to analyze, and I can skip a step, right? Because I have the square root of x squared, which is the absolute value, but since x approaches infinity, lucky me, just x. And the square root, which I cannot do anything to, ever, because it's a sum of terms, plus x. And now it's clear what I have to do. What do I have to do next?
Factor the
Exactly, the denominator, and then I'm almost there. So this is limit as x approaches infinity. The top stays as is, and now the denominator x. So the square root, 1 plus 4 over x plus 1 over x squared, and plus, that's it. Once I simplify the x, then I can drop the limit operator.
Did you get 1 for the x?
I'm sorry?
On the bottom, the plus 1?
X,
The
ti
plus x as
x
well.
times this is this. X times 1 is this. So if you want to distribute it, this times this will give us this, and x times 1 will give us this.
Oh, you factored out an x.
Yes, I have to, because it's the only way to get rid of this. And now I can drop the limit operator. 4 over 2, very good, which is still 2,
Oh, yeah.
but that's okay. That's okay. So then we know something very important about this function. That
It's crazy.
y equals
2.
is a horizontal asymptote. I use the sign. I use the sign of the infinity. I have to say at infinity only, because I use the sign. I ask myself, what is the square root of x squared? If this were x approaches negative infinity, I would have said what?
Negative.
Correct. Okay, so another limit. Yes. Another limit. Oops. Last limit here. Limit as x approaches infinity from 1 minus e to the x divided by 1 plus 2 e to the x. So what do you think we have to do first?
Plug it in.
Say it again.
Plug it in.
Okay. So e to, good. So the top is negative infinity and the bottom is? Good. So it still doesn't matter. The sign doesn't matter. Infinity over infinity is still what type of case? Indeterminate case. Very good. So then now what?
The inner and outer.
So I have limit. As x approaches infinity.
You can factor out the
Yes?
x.
Yes, we will factor out e to the x by force from both. Perfect. Awesome. So then,
1 over e to the x minus 1.
very good.
1 over e to the x plus 2.
Very good. This will go away. And now I have the answer. Where?
Negative 1/2.
Very good. Awesome. What does this mean about the function? What does that say about the function?
Horizontal asymptote.
Right. Y equals negative 1/2 horizontal asymptote. We did not use the plus or minus, so it's everywhere.
What do you mean we didn't use the plus or minus?
So we did not use, well, actually, let me think for a second, because if this approaches negative infinity, this will be 0, this will be 0, this will be 1. So I do have to make sure that this is e to the x. If, like here, for example, we said the square root of x squared, because it's approaching infinity, this is x. If it were approaching negative infinity, it would have been negative x. So here I use the fact that the square root of x squared is x when x approaches infinity. I use the sign of the infinity in the problem. So that's why I have to write this. Here, although we didn't use it, the e to the x, the graph of e to the x is this. So if x approaches negative infinity, this will approach 0, this will approach 0, and I get 1 over 1, which is a horizontal asymptote, which is 1 at negative infinity. So I do have to write this.
So we should just always write x.
So because
Will never be wrong.
that's true. That's true, except for pure rational equations, rational functions. Pure rational functions will not have an asymptote, blah, blah, and another one and the other one. So here, So at infinity, the asymptote is negative 1/2, but at negative infinity, the asymptote is 1. This will not happen with, it happens here because it's a combination of two functions, rational function combined with exponential. But if you have just pure rational function like this one, this will never happen. This is a pure rational equation, a rational function. You will not have 1/2 at one end and negative 1/2 at the other end. That's never going to happen. But function compositions like this one, yes, you have to be careful. Thank you for asking. Oh, he left. Thank you. Very good. So 8, page 8. So we have the limit. Do I have to show this limit? Sx approaches 1. 1 minus 3x divided by 2 equals negative 1 using the precise definition of the limit or the epsilon delta. Okay. How do I start? First of all, I have to check. And the last problem, which is the extra credit, I think you'll have no difficulties. Explain in your own words, how can a function fail to be differentiable? What will you say?
But it can't have a
Yes, if it's not continuous, or if it's continuous, but it does cusp, corner, or
Jump.
vertical tangent. How many cases are there? Explain in detail why the function is not differentiable in each case. Right? It cannot have a double tangent. So the cusp or the corner, it's a double tangent, one here and one here. So for the function to be differentiable, it has to have one tangent at each point. It's not continuous. You cannot have a tangent, because if it has a jump, this is one tangent here, and this is another tangent here, two tangents. Okay, good. So let's start with this. So this is equivalent to, let's check first of all, 1 minus 3x is negative 2, divided by 2 is negative 1. So this is equivalent to saying that for every epsilon greater than 0, I will find a delta greater than 0 such that, very good, less than epsilon. Yes? Less than delta, of course. Sorry. Okay, implies
the absolute value of
1 minus 3x over 2.
plus
Awesome. Less than? Right. So when we looked at this a while back, it looked like it was a foreign language, right? But now it's really just three symbols. If you want to use them, use them. If not, just replace them with words. I'm fine either way. Good. So first step, where do I start?
You have to get that.
Very good. 1 minus 3x plus 2 over 2 in absolute value less than epsilon. Then
Multiply by 2.
negative 3x plus 3 divided by 2 in absolute value less than epsilon. Then we are using the property of absolute value. Or if you want to factor first, let's factor first. What will I factor? Perfect. What is left in parentheses? And make sure that is this. Make sure that is this, right? Okay, an absolute value over 2 less than epsilon. I have to show the property that I'm using, which is the absolute value of, perfect, the absolute value of times. Good, over the absolute value of 2 less than epsilon. Now I have to determine these, so I'm going to move up because I still have room. Okay. So then I have 3, the absolute value of x minus 1 over 2 less than epsilon. And now I'm ready to get x minus 1 less than?
2 over 3 epsilon.
Very good. 2 epsilon over 3. And of course, I've got delta. Why? By comparison. I'm comparing this to this. So then how much is delta? Very good. That's what it is. And in step 2, you know the drill, reverse.
How do you use the sign on there?
Oh, everything has to be positive.
When we do step 2, can we just write reverse? And then
Just say show.
by following.
Show that, yes, that's it. Delta equals 2 epsilon over 3 works by reversing the steps from above. I'm fine with that. Any questions?